solving a linear equation, fractional forms with binomial numerators. All right, so to talk about this word binomial, it just means there's two things, bi meaning two, there's two things in the numerator. So we have a equation, we have two different pieces that have two pieces in the numerator. Students get really freaked out when we start talking about fractions, but I promise you that these aren't that bad. I'm going to start by drawing my wall. If you've seen any of my videos, I draw the wall to make sure that we keep track of our equal sign and we make sure we're doing things on both sides of the equal sign, not just on one. Now, here's the key to this. You want to find the LCD. That's the least common denominator. You have a 2 and a 4 in the denominator. The least common denominator, or the least common multiple of 2 and 4, is 4. So I have the LCD. Once you have the LCD, you want to multiply both sides by the LCD. But when you do that, you want to make sure that you're distributing it to both of them. I'm going to give you a little trick here. 4 times 2 is going to give you 8, so I'll just put that 8 there. Now, technically, it's going to look like 4 times x minus 3 over 2 plus 4 times 3x plus 4 over 4. It's easier to do this. That's my eraser. It's easier to do this as a pointer 4 over 2 and then this in parentheses. So I'll show you how that looks. So I have 4 and then over 2 times x minus 3. This is the same thing as 4 times x minus 3 over 2. It's just you're grouping these together instead. And then on the second one, you have 4 over 4 times 3x plus 4. So simplifying, 4 divided by 2 is 2, so 2 times x minus 3. 4 over 4 is just 1, so 1 times 3x plus 4. And now we're going to distribute. So with the 1, there's not really a purpose of distributing the 1, it's just a 1. So nothing is really going to happen with that second set. 2 times x is 2x minus 2 times 3, which is 6. And then, like I said, there's not really anything that's happening when you distribute a 1. All right, now we're combining like terms. So on the right-hand side, we can combine the x's and we can also combine the constants. So 8 is equal to 2x plus 3x is 5x. Negative 6 plus 4 is negative 2. To get the x all alone, I'm going to add 2. Sorry, my computer just did something weird. Add 2 to both sides. That 2 is going to cancel. 8 plus 2 is 10 equals 5x. Divide both sides by 5. And you'll get 2 is equal to x because those 5's cancel, which is the same statement as x is equal to 2. If you want to check your answer, you can go ahead and plug it back into this original equation. It's not that bad. I'll just go ahead and do it on this first one. So 2 is equal to, instead of x, I'm putting 2 minus 3 over 2 plus 3 times 2 plus 4 over 4. The key to doing this, just make sure you simplify the numerators first and everything will be fine. So 2 minus 3 is negative 1, so we have negative 1/2. Plus 3 times 2 is 6, 6 plus 4 is 10, so 10 over 4. You could use your calculator here. You could do negative 1/2 plus 10 divided by 4, and it will give you 2. So we can feel confident that x equals 2 is our answer. Now, I want to point out that we're not looking for this number to be the same as these numbers. We're just looking for the numbers here to be the same. So if this said 7 equals 7, I would be equally as happy. Let's go ahead and do another problem. So here we have 5v plus 6 over 8 minus 7v minus 3 over 2 equal to negative 15. The LCD, looking at the 8 and the 2, is going to be 8. And if you're having trouble remembering about LCDs, you can definitely look this topic up in Alex, and we have a video for that. So I think maybe what I'll do, since I know it's going to be distributed anyway, I'm just going to kind of write that 8 in there. Now I can do 8 divided by 8 is 1, so these really just cancel. And I can write the 5v plus 6 minus, now 8 divided by 2 is 4. So I'm going to write 4 and then parenthesis 7v minus 3 equal to negative 15 times 8, which is going to be negative 90, negative 120. I do need to distribute, so I'm going to distribute this negative 4 in both places. So 5v plus 6. 4 times 7v is going to be 28, but there's a negative in front, so it'll be negative 28v. A negative times a negative is a positive, so negative 4 times negative 3 is positive 12, equals negative 120. I'm going to combine my like terms over here. 5v minus 28v is going to give me negative 23v. 6 plus 12 is 18, equal to negative 120. Subtracting 18 on both sides to get the v by itself, we have negative 23v is equal to negative 138. To get v completely alone, we're dividing by negative 23 on both sides. That cancels. So we have v equal to, if you have two negatives, it's going to turn out to be a positive. So we have 138 over 23. You can put it in your calculator to see if it simplifies, because I don't off the top of my head know if that simplifies. I assume it doesn't. Oh, it does. It actually simplifies to 6. So v is equal to 6. And that's that. So once again, what was happening, so the step that scares everyone is this step here. I want to reiterate what happened there. So when I multiplied everything by 8 at this step here, the unwritten thing that happened was the 8 over 8 and the 8 over 2 part. So let me just explicitly show you what that looks like. So you have this 8, and it's like you take this whole denominator and just move it underneath that 8. And then parenthesis 5v plus 6 minus, you multiplied by 8, the denominator here was 2, parenthesis 7v minus 3 equals negative 120. And then 8 divided by 8 is 1 times 5v plus 6. 8 divided by 2 is 4 times 7v minus 3 equal to negative 120. And if you distribute the 1, that's going to give you the 5v plus 6. If you distribute the negative 4, that's where you get the negative 28v plus 12. So just to kind of be really, really clear on that, those are where those numbers are coming from. These ones can be a little bit difficult, but once you know the trick, I promise practice makes perfect and you're going to be just fine. So keep on practicing, keep on being your best self, and trying your hardest, and you're going to be fine. All right. I just did the send-off for this, but I realized I want to do one more problem. And it's not easy to edit videos on this app that I'm using, so I'm sorry that I just said goodbye, but I'm doing one more problem. Welcome back. Let's just do one more problem, just because I want to make sure that we've seen enough of these, since these ones are quite difficult. All right, so looking at this guy, looking at the denominators, we have a 3 and a 5. The LCD for 3 and 5 is going to be 15. So I'm going to come in here and I'm going to be multiplying everything by 15. Now I'm going to be doing my trick again where I do the 15 over 3. So 15 over 3 times 4x plus 9 equals, this will be 15 over 5 times 4x minus 2. And then 15 times 5 should be 75. 15 divided by 3 is 5, so 5 times 4x plus 9. 15 divided by 5 is 3, so 3 times 4x minus 2 plus 75. Now I'm going to distribute. So distributing the 5 over here and distributing the 3 over here. 5 times 4x is 20x. 5 times 9 is 45. 3 times 4x is 12x, minus 3 times 2 is 6, plus 75. There are like terms to combine on the right-hand side. So 20x plus 45 is equal to 12x, and then negative 6 plus 75 is going to be 69, so plus 69. Now to get all the x's on one side, I'm going to subtract 12x. From here it's not so bad, right? The 12x's on the right are going to cancel. 20x minus 12x is 8x plus 45 equal to 69. Minus 145 on both sides to get the 8x by itself completely. 69 minus 45 is going to be 24. Divide both sides by 8. That will cancel out that 8 there. 24 divided by 8 is 3, so you have x is equal to 3 as your answer. So not so bad. Definitely want to make sure I got in another example of that, so I'll really send you off this time, tell you you're doing a great job. Good job watching the entire video, sticking through it even though I already said goodbye. Keep being your best self. You got this completely. Oh, I can't. Sorry, I had trouble stopping it, but I'm stopping it for real now. What a mess of a video. You're doing great. You're doing better than me.